Could wormholes make time travel real? That's the question I asked myself while watching Stranger Things Season 5, when science teacher Mr. Clarke sketched a wormhole on the board. One part of that drawing really stood out, the Closed Timelike Curve, or CTC. It's one of the most mind-bending ideas in physics. Here's the theory. First, what is a wormhole? In general relativity, space and time are fused into one four-dimensional fabric called spacetime. A wormhole is a tunnel that connects two distant regions of this fabric. Think of spacetime as a giant sheet. Normally, you'd have to walk across it to get from one point to another. But if you fold the sheet so two distant points touch, you can poke a tunnel straight through. That tunnel is a wormhole. Physicists call it an Einstein-Rosen bridge, named after Albert Einstein and Nathan Rosen, who described it back in 1935 at Princeton. Sounds like the ultimate shortcut, right? The problem is, wormholes are ridiculously unstable. The moment matter tries to pass through, the tunnel collapses. Anything trying to cross gets destroyed. Back in 1988, physicist Kip Thorne and his collaborators showed that a wormhole could, in theory, be kept open, but only if it contained matter with negative average energy density. Physicists call this exotic matter. Unlike normal matter, negative energy doesn't pull things together with gravity, it pushes the opposite way, acting like an anti-gravity force. That's exactly what you'd need to stop a wormhole from collapsing. We've measured tiny amounts of negative energy in the lab, thanks to quantum phenomena like the Casimir effect. But the amounts are so minuscule that they couldn't even hold open a wormhole the size of an atom, let alone one big enough for a human to step through. So even if wormholes exist, it's not clear whether one could ever be big enough, or stable enough, for us to travel through. However, even if we could travel through a wormhole, the path would be open and move forward in time as usual, meaning you'd arrive later than you left, just at a different place. Simply put, wormholes connect places. But what if they could connect times? Under certain conditions, a wormhole can give rise to a closed timelike curve, a theoretical path through spacetime that loops back on itself. It's a solution to Einstein's equations where, instead of moving forward in a straight line, an object could follow a curved trajectory and return to its own past, arriving at the same point in spacetime it started from, but earlier in time. Put simply, it's like walking in a circle and ending up at yesterday. The tricky part is that time travel messes with causality. Take the famous grandfather paradox. If you went back and prevented your grandfather from meeting your grandmother, you'd erase your own existence. But then, who went back in time to stop them? It's a logical loop that physics struggles to resolve. So physicists ask, if you could loop back into your own past, could you actually change it? One camp says no, closed timelike curves are simply impossible. Stephen Hawking even proposed a chronology protection conjecture, arguing that nature itself forbids time loops. Some physicists take a different view, known as the Novikov self-consistency principle. In simple terms, the past can't be changed, only events that fit together consistently are allowed. So if you travel back in time, whatever you do was always part of history. That means paradoxes, like erasing your own existence, have a probability of exactly zero and thus can't happen. Finally, there's the many worlds idea. In this view, changing the past doesn't shatter your own timeline, it simply shifts you into another one. Each choice creates a new branch, so instead of paradoxes, you get parallel histories unfolding side by side. So while the math allows closed timelike curves, whether they can exist in reality is still one of the biggest mysteries in physics. Will time travel become a major part of Stranger Things Season 5? The show could be setting up storylines where characters loop through time, confront paradoxes, or even rewrite events. Write your theories in the comments, I'd love to hear what you think. Like and subscribe for more.